This is a pretty nasty question about a particle moving after this rule. First, we need to find the velocity and the acceleration of the particle in terms of t. So, the velocity is a derivative of the displacement, so we get 2 minus 3 sine 2t times 2 from the chain rule, so we get 2 minus 6 sine 2t. Acceleration is the derivative of the velocity, so we get minus 12 cos 2t. Again, I use a chain rule. Okay, we need to find between t equals 0 and t equals 3 when the particle is at instantaneous rest. It is at rest when v of t equals 0. So, sine 2t must be a third. Therefore, 2t can be 0.3398, which is inverse sinus of a third. Make sure your calculator is in radians. The next value is pi minus 0.3398. And I need to continue because t is between 0 and 3, so 2t must be between 0 and 6. 6 is about 2 pi radians. So I need to continue with 2 pi plus 0.3398, 3 pi minus 0.3398. Therefore, t is going to be 0.3398 divided by 2, 0.1699, 1.4009. I give all the answers to 4 decimal places. 3.3115, 4.5425. These are the times when the particle is at instantaneous rest. Next question asks the distance traveled in the second. If we think of the number line, it starts when t equals 0, t equals 1. This is the first second. So our second is between 1 and 2. What happens between 1 and 2? So we see that at t equals 1.4009, the particle is at instantaneous rest, meaning that it can change the direction. Or at all other times between 1 and 2, the velocity is never 0. So the particle is going in the same direction. So I input in the calculator the function for s of t, which was 2t minus 3 plus 3 cos 2t, I believe. And I make a table of values for t equals 1, 1.4009, and 2. And I learned that at t equals 1, s of 1 is negative 2.248. At t equals 2 is negative 3, so at t equals 2 is negative 3.027. Here the particle is at instantaneous rest, and if we put t equals 3, we find that for t equals 3, s of t is negative 0.9609. So the particle travels from t equals 1, then turns and goes here. The total distance traveled is 3.027 minus 2.248 plus 3.027 minus 0.9609, which gives me 2.84 to three significant figures. Okay, last question is quite easy. We remember that v of t was 2 minus 6 sine 2t. So when t equals 2, v of 2 equals 2 minus 6 sine of 4. Put this into your calculator in radians, and that's it.